Welcome back to the live broadcast on KTAL LP, Las Cruces, New Mexico, 101.5 on your FM dial. Also live streamed, lccommunityradio.org or radioketal.org. That's Quetal. This is Science. Let's take a look. I'm your host, Vince Gucic. We're talking with guest John Nelson, an engineer. We went through a lot of his history, how he became an engineer, why he got interested in it. We just finished up a story about working on the Apollo 11 mission, and also about how he got interested doing science projects and so on. So I guess the next thing to go on is what was NASA overall doing at the time you got involved there?
Well, at that time, NASA was getting a lot of money, and it was amazing to get this job done within a decade. President Kennedy said within a decade we'd be on the moon, and people probably thought that's the craziest thing they ever heard, but they made it happen, and the money was flowing. But after that, I think NASA's done a lot of science and robotic things like to Mars and everything. So they've been good with that. The manned space program is probably a little more problematic, although the space station is a great success. And they had a design for a space station, but couldn't afford it, so we bought a Russian space station, and that's how we started the space station.
Ah, okay. Yeah, that's tweaking my memory there.
Yeah.
Now, NASA also got involved with like the environmental monitoring by satellite. And I'm trying to remember what the partnership NASA with NOAA, the National Oceanic and Atmospheric Administration.
And I don't know.
I think NASA put up the satellites and NOAA runs them, if I have that right.
I think that's right.
Right. And that's been invaluable for weather data. How are you going to know where the hurricane is? That's only one of the high-profile things, but there's infinite amount of, well, not infinite, but a great deal of information available thanks to those programs.
Yeah. Well, back in the 70s and 80s, NASA was starting to say, what they should be doing is pressing the envelope as far as science goes. And they were saying, hey, we should get industry doing some of this more mundane stuff. And I don't know how many people have been following SpaceX lately, but I think last year they had 17 launches. They launched quite a few satellites, and they have supplied the space station 3 or 4 times. I'm not sure how many. So I think that's a great move on NASA's part, is moving away from doing everything themselves and relying on industry and what they're doing now with SpaceX. They just picked 2 or 3 companies and they had a competition.
Right.
And
what's another one is Blue Origin, if I remember.
Blue Origin is one, and I can't think of the
third one.
Yeah.
But, and these are all the .com millionaires, right? Like Elon Musk is from eBay. That's where he made a lot.
Started eBay, yeah.
Right.
And PayPal.
Oh, okay. And then there's Jeff Bezos from Amazon.
Yeah.
And I think he's Blue Origin.
He is, but I don't think he's doing anything with NASA yet. He's doing his own thing.
Right.
There's another organization, which I don't recall right now, that's also launching for the space station. Anyway, I mean, that's a real important move that NASA made. And Elon Musk, his point is government in general ought to use that approach more often, use competition, find somebody who wants to do the job, and be a
right.
lot.
And I would say, get the for-profit group in there. I don't know if Elon Musk is making any money. I think he's losing money. He just loves to do this stuff.
That's right. I think, well.
But he's willing to take risks and jump over a lot of steps so that he makes faster progress and it's cheaper. He hasn't risked any human lives yet, but he's about to engage in a mission with humans on, delivering people to the space station, as I recall.
He is. That should happen this year.
Really?
And they're trying to qualify their Dragon capsule for carrying people, and they expect that that's going to happen. So, and it'll save a lot of money because right now we pay Russia for every launch of astronauts to the space station and bringing them back.
Right. And that Dragon rocket is the most powerful rocket ever made, as I recall.
It's the Falcon. Well, Falcon is the rocket.
Falcon is the rocket. Okay. Dragon is the capsule.
Capsule.
Oh, okay, yeah.
And later this month, they're supposed to launch Falcon Heavy, which would be the biggest by a factor of 2 of rockets in existence right now. I mean,
and was that supposed to be able to lift 54 tons into low Earth orbit?
Yeah.
Yeah.
That's a lot of weight.
Yeah, when you consider the rocket equation, which we don't have time to get into, you have to use up a lot of propellant mass to get a small amount of payload in. When you consider that let's see, could I say this? Okay. The final velocity that you can achieve as a fraction of exhaust velocity is basically the natural logarithm of initial mass over final mass. So if you expand 90% of the mass of the rocket, the natural log of that is 2.3. You can get 2.3 times the exhaust velocity. And the exhaust velocity is about, 40% of what you need to get into orbit. So you got to have stages.
Yeah. And another really important thing that they've been doing, and one of the reasons why using a contractor is that Musk said, hey, to make this cheaper, I need to retrieve the boosters. And he's landed, amazingly, he lands his first stages back at KSC, or if they're further out in the ocean, on a barge.
Yeah, it looked to me when I saw the videos like he was trying to land a pencil on its eraser.
I know. But he's successful. He's doing it over and over again, and it's going to reduce the cost of going into orbit.
Yeah.
So,
well, as they say, who'd have thunk it?
Right.
And that it was even possible.
Yeah.
So, I guess that's a lot of your story. And what I'd like to go into, since this is nominally a science show, is where does technology come in and where does math come in? Sorry about that. Science is looking for fundamental concepts and processes in the natural world, and engineering is applying those. But the division between those two isn't so clear. So science depends on technology to advance, and then the reverse happens. Like, you get the right technology and you can do more science. I've got a number of examples there. So if you look at precision atomic clocks, that was basically driven by it's now NIST, National Institute for Science and Technology, and it used to be National Bureau of Standards. So they developed extremely precise clocks, and now, how does that give us new science? Well, you can call the GPS system part science, and it made that possible. It also made things like LIGO, the Laser Interferometer Gravitational Observatory, possible, because you have to time things within, nanoseconds, picoseconds, whatever, when you're looking for those gravitational waves. And then if you look at things like isotope mass spectrometry, where you can get a sample with certain chemical elements, and you ionize these and apply voltage, get them flying, and then bend their trajectory with magnets, and you can find the masses. You can therefore find out how much you have of this mass of carbon and that mass of carbon, like carbon-12, carbon-13. That opened up an enormous amount of study in, say, physiological ecology, which is a thing that I did for a good part of my career. It's now used on global scales to find out what's going on with ocean temperatures, global warming, and so on. So the technology led that all to happen. And then, of course, the scientists using this say, hey, we could use a little tweak here. Can you do this? Can you give us molybdenum and so on? And so they do it. So they're working hand in hand. And then both of these enterprises, science and technology, use a lot of math. That's not to be something daunting for anybody considering a career in either one, but get that math, and math is fun. I looked at the list of courses that I've taken over the years, and it's a very long list, and I think of some of the things that were really, really inspiring. Calculus, of course. I use calculus every day, even now. I guess I'm sort of an addict. But there's also, let's see, I helped our son with some interesting calculations with tensor mechanics. He's studying the properties of gels, and ultimately with application toward artificial tissues, for grafting on burn victims and so on. The math course that I enjoyed most of all was complex variables. I don't use it very often, but it was such a romp through logic and quantitative stuff. And I only took it because I thought that the differential equations course, which should have been more valuable to me, was being taught by the coach. And he wasn't very good. So I ended up in a very rewarding course. And I've also taken a lot of time after John finished with a lot of insights. So we're going to take another little break. You remember, you're listening to KTAL LP, Las Cruces, New Mexico, KTAL. And we're also 101.5 on the dial. We're also streamed live, lccommunityradio.org and Radio KTAL, QUETAL.org. You'll also find places where on those sites where you can become a member and also consider underwriting. And I'll tell you a little bit more about underwriting when we come back after a few minutes.